The skull of vertebrates evolved in stages. So the human skull is composed of three separate regions: a splanchnocrinium, this is the oldest section, the chondrocranium, the second oldest, and the dermatocranium, which is made of dermal bone. The dermal bone appeared in late jawless fish for the first time. And these jawless fish and the placoderms, the most primitive jawed fishes which followed them, possessed big plates of bone. Now, while these big plates of bone in the head region are significant, just as in the human fetus, bone develops in the head region as dermal bone, while the rest of the skeleton develops as cartilage first that becomes bone. Dermal bone in the skull was significant, but these big plates are not homologous to the bones which are present in the skulls of humans or the modern osteichthyans, the name for the bony fish, the amphibians, the reptiles, birds, and mammals. So later groups of fossil fish, like the acanthodians, which now have many small bones in their skulls, and the first bony fish, the osteichthyans, are significant. The first bony fish now have bones which actually match those bones possessed by humans and other modern osteichthyans. This is why the discovery of a placoderm named Entelognathus is especially significant. It was known from the Silurian period, between 443 and 419 million years of age. And like other placoderms, it possessed large bony plates in its skull and in its trunk. However, around its jaws are smaller bones, which seem to be homologous to the bones of the osteichthyans, such as the bony fish, but then also the tetrapods, including humans. These bones were thought to be unique to osteichthyans, but now it turns out that while the first placoderms lacked them, later placoderms, more closely related to the osteichthyans, actually developed a maxilla. This is the bone of the upper jaw which holds the teeth. The premaxilla, the dentary bone of the lower jaw, the lacrimal bone in the orbit, the jugal bone, which humans call the zygomatic, perhaps the quadrijugal bone in the jaw joint, and the opercular bone, which covers the gills in modern fish. And so here we see a transitional form, which still has the basic organization of a placoderm skull, but now with some of the smaller bones which would make up the skulls of osteichthyans. These small bones were once thought to be unique to osteichthyans. If one were to group fossil fish according to anatomical traits, one observes a nested hierarchy of relationships where there are groups and then groups within groups. So this varying degree of relationships. Entelognathus is in between the placoderms and then the later fish, including acanthodians, chondrichthyans, and osteichthyans. So it seems to be a transitional form, while primarily displaying features of the placoderms, also having features which link it to higher fish, which other placoderms lack.